All right, good morning, everybody. Welcome to Couchbase Connect 2016. Thank you very much for joining us, especially on this rather important day. So today I want to talk about going all in, from a single use case to many, and the story of using Couchbase at LinkedIn. I really want to walk through how LinkedIn grew as a business and how our hypergrowth period in the late 2000s sort of really pushed us to search for some really good solutions into read scaling, and how Couchbase filled those needs quite nicely. So I want to talk about the LinkedIn story in general and how we came to this place, and touch on the different ways we use Couchbase at LinkedIn. We've got sort of four distinct ways that we use Couchbase at LinkedIn. And thankfully, from the way that Couchbase is operated and architected, we can make all these use cases work really well within the LinkedIn infrastructure ecosystem, and make my life a lot easier as an operations engineer. Then I want to walk through development and operations of Couchbase at LinkedIn. So how do developers develop against Couchbase, and how do we operate Couchbase from an infrastructure point of view? I want to talk about a couple of things that we've learned, and then I'm happy to take some questions. So who am I? My name is Michael Keogh. I'm a staff site reliability engineer, or SRE, at LinkedIn. I'm on a team called Production SRE at LinkedIn. So my team is responsible for driving major incidents. We also work on monitoring strategies and helping ensure that we give the member the best experience possible when they're using LinkedIn. I've had this question before while I'm talking. I do have a funny accent. It is Australian. Please don't mistake me for being English. If you want to contact me after today, feel free to find me around the conference, or you can reach out to me at Michael K. Keogh on LinkedIn, or Matrix Tech on Twitter. So what is SRE? So who in the audience is familiar with the term SRE, or I see a few hands, or DevOps, a few more? All right, so SRE stands for Site Reliability Engineering. And we're basically operations for the production application environment at LinkedIn. So anything that is member-facing or is used in the member experience, we're responsible for operating. You can think of us as the ninjas of the digital economy, the people working behind the scenes to make sure everything works smoothly. So at LinkedIn, we actually use ninjas as a representation of our organization, and was able to dig up this logo, which probably represents what we do pretty well. So what are our responsibilities? So architecture design, so for both things that are member-facing, and also like production tooling. Capacity planning, make sure that we've got enough capacity in our infrastructure to serve the member, and that we can do disaster recovery if possible. Operations, so making sure that our applications that we support run smoothly, they're well monitored, they're performing well, they've got the right automation in place, and that also extends, of course, to Couchbase. And then the other part of our job is tooling, so writing tools to make our lives easier as SREs. So I'm a member of what we call at LinkedIn CBVT, which stands for Couchbase Virtual Team. So the Couchbase Virtual Team is a team of approximately 10 engineers, 10 SREs, sorry. We have 2 software engineers, and our group is sponsored by an SRE director. So you might be asking, what is a virtual team? So at LinkedIn, we have this concept of virtual teams, where if I have an interest in something, I can go and join a virtual team and have some of my time allocated to working on this interest area of mine. So typically at LinkedIn, that will vary from anywhere to 5% for light contributors, anywhere to sort of 90% plus for leads of those virtual teams. We encourage as many people to contribute to the Couchbase virtual team as possible. This helps us, number one, get more resourcing on things that we want to achieve. It also helps spread knowledge around how to use Couchbase if you run into some trouble, how to get yourself out of it. And as I'll touch on continuously during this presentation, it's really helped us build a good ecosystem around the use of Couchbase at LinkedIn. So what does CBVT do? So we do operational work on our Couchbase clusters. So all of us are part of the group, are basically owners of a Couchbase cluster at LinkedIn. So we'll be the ones driving a lot of the operational work around those clusters, whether that be capacity planning or failing nodes in and out for hardware maintenance, et cetera. We help evangelize the use of Couchbase at LinkedIn, which is something that's really important. Since we started using Couchbase about 4 years ago now, we've really taken it from something that was a proof of concept to basically the #1 caching solution within LinkedIn. And of course, we develop tools for the Couchbase ecosystem, which I'll go into a little bit more depth later on. So the LinkedIn story. So LinkedIn was founded in 2002, launched on Cinco de Mayo in 2003. And LinkedIn has grown into one of the world's largest professional social media networks. We have 30 offices across 24 countries, and we're available in 24 languages. So, in the past nearly 15 years, we've built this massive online digital economy for people to help go and find jobs, for recruiters to advertise jobs, for people to go and learn, and find a way to connect with their peers on a professional level. So we've been able to build up a member base of over 450 plus million members. We're nearly to 470 million worldwide. So we've got a significant user base, and of course, with a large user base, we need to be able to scale our infrastructure in a smart and efficient way. So LinkedIn started off with profiles, which are still core to what we provide today. We moved on to professional groups, and now we have Recruiter, which is probably what we're best known for in terms of products, and Sales Navigator, which is a newer product which helps salespeople find leads. Our growth of internet traffic is up into the billions of page hits per day, and our backend systems will take hundreds of thousands of QPS in order to serve our members. So LinkedIn started as an all Oracle shop. We still have a fair bit of it around. And while LinkedIn was young, this was great. It worked well. It was stable. The challenge you have is that while Oracle is fine for writes, it takes a fair bit of work and traffic to sort of hit a concrete ceiling there. Read scaling is a larger challenge. And as we went through the hypergrowth phase of the business, those scaling challenges for our infrastructure became pretty important fairly quickly. So for some of our systems, as you'll see today, we're scaling our reads into the hundreds of thousands of QPS on a per service basis or per Couchbase cluster basis. And of course, as you scale your reads, you need to have very resilient infrastructure. So if I have a solution to scale my reads that fails, and all that traffic falls back onto my back-end database, it's very easy for me to take that database down. So having resilient infrastructure is extremely important. So when we started using in-memory storage, the use case was fairly simple. It was just around basically read-through caching. It'd be nice to have it pre-warmed, but that's what we needed, read-through caching. And we needed something that was had the potential to be a source of truth store at some point. So until 2012, we were only using Memcache to do the source of truth in-memory storage. So if any of you have operated a Memcache cluster, you probably know some of these drawbacks. So it's very difficult to pre-warm. You basically, if you start a new cluster, everything is, all your cache is cold. Everything will basically go through to your backend database. There's no native partitioning or sharding, and so we had to go and write our own, and it's something that is still sort of a dark art at LinkedIn on how that works. Cold cache restarts. We did at least have a significant footprint in terms of hardware for Memcache. And with a significant hardware footprint, you need to take servers down for maintenance. And if you're taking Memcache servers down for maintenance, you basically end up with a server back in your pool that's completely cold and needs to be rewarmed. And one thing that has sort of been an interesting challenge is it's difficult to move data across hosts, clusters, or data centers. So every time we build out a new data center, it was really challenging to sort of try and copy some data across, or if we're expanding the cluster and needed to do it sort of quickly, it was actually quite a challenge. So in mid-2012, actually before I joined LinkedIn, we started testing Couchbase. So at the time, we're looking for something out there that was sort of better than Memcache, something that could fill these sort of drawbacks that we were having. So we looked at Mongo, Redis, and a couple of others, but we saw that Couchbase had some distinct advantages. We could simply replace Memcache, which I'll talk about a little bit more, had built-in replication and cluster expansion, automatic partitioning, which was something that was sort of important to us. It was extremely low latency. We could do async writes to the disk, so they weren't blocking writes. We can sort of dump a large amount of writes, if needed, onto a Couchbase cluster, and we can let Couchbase sort of catch up and write to disk if possible. And Couchbase is pretty easy to tool around as well, which is something, as an SRE, I very much appreciate. So using Couchbase at LinkedIn today. So we run Couchbase in our corporate, staging, and production environments at LinkedIn. So basically, any in-memory storage that's in the data center is done via Couchbase. So some numbers for people. So across production and staging, we have 148 buckets, nearly 3,000 hosts, and we serve about 10 million plus QPS across all of those servers and clusters. In terms of ceiling numbers, so the largest cluster we have is 72 hosts. By documents, we have a couple of buckets with about 1.4 billion documents. And by QPS, and I'm pretty chuffed by this number, we have a cluster that does 2.5 million QPS, which is queries per second, on a relatively small cluster, which is absolutely awesome. So how do we use Couchbase today? So I talked about the simple read-through cache, which is obviously the most common use case. But we also, as our infrastructure developed and we needed some more features in in-memory storage, we're able to do some other things with Couchbase. So we can use it as an ephemeral counter store. We use it for deduping data, so duplicating data. And for SREs, we also use it as a source of truth data store for some of our internal tools. So let's deep dive into some of those use cases. So firstly, simple read-through cache. So we wanted something that could fairly simply replace Memcache. So something that we could basically read, scale, and protect our backend databases. So one of the good examples of that at LinkedIn is our third-party ingestion credential cache. So at LinkedIn, if you go and do a share, or if you go and say, set up a Twitter account, so if you share something on LinkedIn, it tweets out to your Twitter, we need to store those credentials. So we have a credential cache, basically, which we put in front of our Oracle database to basically protect against large amounts of traffic. So you can see from these graphs here, and just to make it clear, all the graphs that I have are standard Couchbase metrics fed into our own in-house monitoring system. So on the top left, you have aggregate QPS per data center. So you can see that with this particular bucket is doing about 1.4 K, so 1,400 queries per second to the bucket. We've got a pretty good cache hit ratio. So we've got, that's about 97, 98%, which are basically queries that are going to Couchbase instead of going to the backend Oracle database. We have over 100 million total items in the buckets per data center. And of course, we keep that all in memory. While everything's on disk, we want to make sure that our whole working set is in memory. So what this does is it gives us a flexibility to scale our systems really easily. We don't have to go and buy more expensive hardware to run several databases. We can simply put a cache in front of this, have faith that we're not going to have any problems where if we lose a node, all that traffic's going to go and hit our backend database. We know we're protected, and we can go and scale this system. Second use case is counter stores. So in some places, we need to just simply increment counters from using source data from multiple systems. So the main use case for this at LinkedIn is our anti-abuse and anti-scraping systems, commonly known as Fuse within LinkedIn. So every time you go and view a page at LinkedIn, that sends a page view event through our systems. And this Fuse system goes and collects all those page view events and basically counts how many pages you as a member or a user of LinkedIn have viewed in the past 24 hours. So you can see that we're doing, per data center, maximum is about 250,000 QPS. And the interesting thing you'll notice on the right is the total items in the bucket. So every 24 hours at 0:100 UTC, we basically drop everything in that bucket and then reset the counters for the next day. So the good thing about this system is if we lose a node, we sort of protect ourselves from any potential for abusive scraping. We can simply rebalance the cluster, and we don't really lose any data. So we can ensure that our systems are staying protected, and our member data isn't being public member data is not being scraped by bad third parties. Deduping stores. So we have a number of systems for email at LinkedIn, and we have the use case where we need to basically deduplicate data from different systems and across sort of large clusters. So our email system, our use case here is we basically don't want to send the same email twice. So in our email systems, we use Kafka to basically transport outgoing emails within LinkedIn. If you haven't heard of Kafka, it's basically a distributed messaging queue that scales to rather large sizes, and is probably seen in the open source community as the best tool for large-scale message queuing. So with our email systems at LinkedIn, we have basically all these emails that are moved around internally between our infrastructure within Kafka. And we do have the ability to hit an edge case where we can sort of consume the same message twice, because of the way that Kafka works and the distributed nature that it consumes messages off this message bus or queue. So what we want to do here is we want to ensure that we don't send the same message twice. So in the email, we basically set a unique string that sort of represents the email and who it's going to, and we store that into Couchbase. So as you can see on the graph here, this is the number of set operations we do into that Couchbase bucket. So as you can see, basically at the top of every hour is when we process a lot of email and send a lot of email. So we basically these unique email identifiers. Of course, when the email system is sort of consuming these messages, we go and check in Couchbase if we've already consumed that message and sent that email. And then the final use case is a source of truth store for internal tools. So SREs love Couchbase at LinkedIn. Obviously, it's schemaless, so we have the ability to go and make changes and prototype very quickly. Very short setup time. It takes a little bit of time to get, like a MySQL store or an Espresso store, which is another in-house database we have at LinkedIn. It takes time to get that provisioned. Couchbase is much faster. I can go and have, a bucket or a cluster set up very quickly. I'm talking less than an hour using all that automation. And we also have the ability to use views for simple map producers. So for certain use cases, we can use secondary indexing to go and get data out, and we can sort of softly massage the data. We don't currently run, we're running Couchbase 3.1 as our latest version internally, so we're not using any of the nickel features yet. So some of the use cases that I wanted to highlight is Nurse, which is our auto remediation system. We store a huge amount of data actually in this cluster, and Nurse is our auto remediation system at LinkedIn. So we basically keep a store of all the auto remediation jobs that are fired, all the different plans, the settings for the system, all in this store. And again, we use views to heavily massage some of the data into really easy to use ways. Traffic Shift In, that's a tool I wrote, and it is a global traffic automation system at LinkedIn. So the traffic shift APIs are hit by a number of different systems within LinkedIn to check how our traffic is distributed across our data centers. And so our alerting system heavily uses this to work out should we suppress alerts or not. And there are a number of other tools within LinkedIn that use this. So what the traffic shift tool is gathers a metric once, and then we go and cache it into Couchbase. And I know that they can scale really easily, and I don't basically need to build out my infrastructure to serve huge amount of reads. I can let Couchbase do all the hard work for me. Then our availability monitoring. So we store basically our availability numbers for LinkedIn.com all into Couchbase at a minute granularity. And then we use, again, views to do map reducers and get this data back out and run reports for our executives. So I spoke earlier about the Couchbase ecosystem. So I want to show you what that looks like. So let's start at the top, where we have our sort of interfaces into Couchbase. So LinkedIn is primarily a Java stack. And we've actually written our own wrapper around the Couchbase SDK, which I'll get into a little bit more detail in a minute. So we have Java and Python clients. We have the ability to push data from Hadoop jobs into Couchbase, whether this be for pre-warming a cache or disaster recovery. And then we have the actual Couchbase cluster and Couchbase server. So we run bare metal hosts, and we have Couchbase server installed. And we have this daemon called AMF CB stats, which is AMF stands for Autometrics Framework. And we basically collect statistics about the host and the bucket, and we push that into our monitoring system called ingraphs. That data also goes into our alerting system, auto alerts. And we can get some nice looking graphs and good data from all those metrics in a simple way. We've also got a fair bit of management and installation tooling as well. So we use SaltStack to deploy Couchbase currently within LinkedIn. And we store all the sort of metadata about how we want those clusters to be configured and look in a range, which was originally written by Yahoo. And then we've got sort of a global sort of dashboard that shows how we use Couchbase at LinkedIn in terms of like who owns clusters, what buckets are in each cluster, some of the key settings that we care about in a tool called Macys, which I'll show in a little bit. So going back to developing around Couchbase, so we have, our own wrapper for the Java client, which is called LI Couchbase Client. So basically, it's just a simple wrapper, but we do a few other things. So we do custom metrics emission. So from the client side, where we're using Couchbase, we can get some good metrics out. So we're talking about call counts, hit rates, error count totals, and latency. This uses a Spring interface, which is super useful for us at LinkedIn. When I was talking about sort of replacing Memcache, the way we were able to write the wrapper is we more or less made it nearly a drop-in replacement, where we could just change the Spring wiring in our Java WAR, and we don't actually have to change any code to move from Memcache to Couchbase. So originally, we're using Memcache to store Java serialized objects, and we basically did the same sort of thing here when we moved originally, just storing everything in Couchbase in the same format. For Python, we just use the open source Couchbase Python client. In the future, we'll look to probably create our own wrapper again to do sort of metrics emission, which is super important to look at your client metrics when you've got more than one application using a Couchbase bucket. So operational tooling. In order to use Couchbase efficiently as SREs, we sort of have the following requirements. We need to have provisioning, installation, monitoring and alerting, and infrastructure visibility, which is what I sort of talked about in the ecosystem. So provisioning. So when someone wants to use Couchbase as a caching solution, we, as a Couchbase virtual team, us engineers to work out what the usage statistics of the cluster would be. So how much data they're going to store, how many queries per second that will go to that cluster or that bucket, and what their data redundancy needs are. Then we go and calculate the cluster sizing. So we have our own in-house template, but Couchbase has a nice little tool online at that URL where you can sort of program in the constraints that you have, and it will tell you, how many servers you need to acquire. And then so once engineers and SREs have gone through this process, they go and request their hardware, and they get it shortly after. So in terms of installation process, so we enter cluster metadata into our management system range. So we sort of store, who owns that cluster, what buckets are on that cluster, what alerts we want to have for those buckets. And we use salt states to install and configure the clusters. One of my colleagues, Isa Fatah, has actually written a blog post available online that goes into detail a little bit more on how we do this with a little bit more detail. So the benefits we get from this is being able to perform state enforcement, so we can ensure that what we desire is what we get. And we also use salt pillars to encrypt cluster and bucket passwords end-to-end. So we don't store passwords anywhere in clear text in any of our management systems. We use GPG encryption and salt pillars to keep the data secure, basically. So monitoring and alerting. So we want to grab, we want to get data from all of our Couchbase servers on how they're performing. So we run a daemon on each Couchbase server, which sends metrics to Ingraphs, which is our in-house monitoring system. So we simply have a wrapper, this daemon that calls the Couchbase APIs, gets this data, emits it, and I see it 1 or 2 minutes later. And then going back to using that cluster metadata, we go and build dashboards. And while I'm talking about monitoring, I just want to quickly plug the monitoring production employments talk that I'm doing with Alex Ma from Couchbase, that talks about how to monitor Couchbase, which is in Great America 1 this afternoon at 4 p.m. So what do our dashboards look like? So this is a simple overview. So we actually take every single metric that Couchbase emits and push it into Ingraphs. Obviously, I probably don't care about every single metric. So what we do when we generate this dashboard is we sort of put the important metrics at the top. So what is my QPS? What is my hit ratio? How many items do I have in the bucket? Is all of my items in memory? How much memory am I using? And how large is my disk queue? And so when we build these dashboards, we also create the alerts basically for free, so SREs don't have the overhead of having to manually create, and curate, and maintain alerts for their Couchbase buckets and clusters. And then operational tooling and management. So we wanted to see what the world view of all the clusters we run looks like, and get some bucket level or server level or cluster level statistics, which we can sort of roll up, if need be, into reports. And we also needed to have like a global view of who owns and operates each cluster and bucket, and sort of what services talk to those clusters. So we built this tool called Macys. Unfortunately, we were trying to name this after places where you could buy couches. IKEA was already taken internally, so we called it Macys. So this sort of shows on a bucket level this particular screenshot where we deploy each of the buckets, what versions of Couchbase they're running, do we have failover turned on, and how long ago was it since someone wrote or I guess updated the dashboards. So what can we conclude from our use of Couchbase? So Couchbase was a natural fit into our existing infrastructure. We were very easily able to replace Memcache using our own wrapper and using the Spring interface. And what we've learned is building an ecosystem around Couchbase was extremely important to us and has helped Couchbase be successful at LinkedIn. If you create friction around the tooling that you have, people will generally go out of their way to sort of not use it. So creating simple, easy-to-use tooling, creating good documentation, having like a knowledge base for engineers and SREs was something extremely important to us and has helped Couchbase be really successful at LinkedIn. So in the future, we're going to keep expanding our use of Couchbase. So since I spoke here last year, we've grown the number of buckets that we have by 50%. We're starting to use more of the features in Couchbase. So we're using views. And I'm sure there will come a time, sometime down the track, where we'll start to use Nickel. And we're starting to look at using rack awareness as well. The other thing is moving Couchbase into the LinkedIn standard deployment infrastructure. So all of our applications at LinkedIn are deployed by an in-house system. Third-party tools are sort of exempt from that, or third-party systems. So we're actively trying to work on moving Couchbase into our own deployment infrastructure to sort of, again, reduce the friction for engineers. And this will open some really exciting avenues on how we can do some really cool things with Couchbase and scale systems really quickly and easily. It'll also allow us to enforce that we've got the right monitoring as soon as that bucket or that cluster is deployed. So that concludes my part of the presentation. Any questions from the audience? Down the back.
Do you use node auto failover, and how long does it take you to monitor and respond to a failed node?
So the question, actually, the gentleman's got your microphone. Would you like to repeat the question?
Do you use auto failover for your clusters, and how long does it take you to monitor, recognize, and respond to a failed node?
So the answer is generally yes. So we set the auto failover at 120 seconds, which is a little bit higher than what the default is. We have noticed some issues where I think it's like at 2 a.m. Pacific time. There's basically a scan on of all the keys, which can sometimes slow down the Couchbase cluster and it loses the heartbeats on the failover. So we've bumped that up to 120 seconds. So we do auto failover, and we've actually got some auto remediation in place that if the client doesn't sort of doesn't pick up the new vbucket mapping, we can sort of bounce the Couchbase client and sort of ensure that we don't have misdirected queries to the wrong vbuckets. In terms of how quickly we respond, so if this, once the auto failover goes off, we have a signal to SREs within probably 4 or 5 minutes. And that can be a phone call, that can be an email. It depends on the criticality of the cluster. Down the front.
So
and Mike,
documents, like when you add or remove nodes, how does rebalancing affect your code?
So the question is, when we're rebalancing nodes in a Couchbase cluster, how does that affect our performance? So it does depend on how heavily utilized that cluster is. We're obviously at sort of the extreme end of pushing Couchbase to its limits, like 2.5 million QPS. It can be challenging. I probably am not in the correct position to sort of say with authority, how Couchbase performs. We are using sort of older versions, but like for anything that's less than probably 50,000 QPS, it's not a problem at all. When you have a lot of writes, that becomes a bit more challenging. So at the moment, because we are, we're trying to protect the member experience, we'll generally fail either fail traffic away from that cluster if it's got a hot standby cluster, or we'll fail out of that data center, just to be sure. Question down the back.
hey, Michael, thank you for sharing about the use cases. It's very encouraging. Is there any intentions in your future roadmap to use Couchbase as an SOT for any external data?
So we're definitely looking down that way. At probably the same time that we started using Couchbase, we started developing a key value store called Espresso, which has basically become the sort of default source of truth store at LinkedIn besides Oracle. So we're sort of definitely looking at, how does Couchbase fit into that picture? Certainly some of the new features I think that were in the 4.0 release clear up some of the conflict resolution things that were sort of inconsistent with the policy that we use around conflict resolution. So that definitely opens up the opportunity to use it more for sure. At the moment, we're just using it for internal tooling, and as an SRE, we love it. It's flexible. We can get started really quickly, and we don't have any friction in operating it. Down the front here. The gentleman's coming with a microphone.
So I think when you were talking about the Kafka data pipe integration, it was sounding like we were using Couchbase as a deduplication kind of tool.
Yep.
Have you looked at, or do you have any use cases for producing Kafka messages via the connector, the DCP client?
So not at the moment. We're certainly aware of the existence, of that tool. We just haven't found the right use case for it yet. So yeah, when we for the email system, we're doing a lot of sanity checking within the email system to make sure that we're validating the IDs are correct, they make sense before we sort of interface with Couchbase. So we can't sort of have like a direct connection between the two, just because the way that we do our data validation is extremely stringent. So try and protect against any problems. And obviously, we send a lot of email a day, so one sort of small mistake can become large quickly if we mess something up on our side. In the middle over here.
Yeah, so I understand that you guys are not using the enterprise version. Is that true?
Yes.
Okay. So I would ask the question as, what are the kind of support challenges that you would have with Couchbase in general, bugs, rectification of those bugs, etc.?
To date, and I'll knock on wood here, we've been fairly fortunate. Couchbase has been extremely stable. Any sort of bad bugs we've had have been from sort of older releases that Couchbase have told us to move off. So it's not that much of a challenge. The CBVT group, we try and keep like an internal repository of all the different issues we've seen at Couchbase, how it occurred, how we fixed it, do we have like a known fix? And it probably taps into a sort of a good question, why don't we run your versions? So as I mentioned before, we have like 148 buckets, and we have say 7+ data centers. So sort of updating Couchbase to newer versions on each one of those clusters is not it's a time-consuming task, and one that has to be done with a fair amount of care. So certainly if people like say the Fuse example, where they're really pushing the limits of what Couchbase can do and sort of hitting that potential ceiling, we recommend them to make sure they're on the latest version. Otherwise we'll allow sort of 2 different versions of Couchbase running within LinkedIn. So ideally we'd like to get rid of all the 2.2 Couchbase servers before we start looking at like 4 or 4.5. Down the back in the middle.
Are you running in cloud, and could you comment on the size of the cluster that was supporting 1.3 billion documents in one bucket?
No, we're not running in the cloud. It's all on our own bare metal in our own data centers. The size of that cluster, I think, was 32 nodes with 64 gigs of memory. There's nothing particularly special with those boxes. I think the only sort of interesting thing is that we do actually put SSDs in the really high traffic Couchbase clusters where, writing to a spindle is not the best idea.
So on those hosts, are those running on ESX or some virtualization platform, or is that raw metal?
No, complete bare metal on Red Hat.
Okay, thanks.
No worries. All right, I don't see any more hands, so thank you very much for attending today. I really appreciate it. Please feel free to reach out to me if you've got any further questions. Thank you.